On September 12, 2025, astronomers detected something that shattered every expectation they had about how the universe behaves. A colossal object came blazing in from the darkness of deep space, with a tail stretching across the sky 5 times the width of a full moon. It was so enormous that even amateur astronomers with backyard telescopes could see it. Within hours, it was confirmed that this was no ordinary comet. It was something far larger, far brighter, and far stranger than anything we had ever recorded. Officially catalogued as CR 2025 R2, and now simply called SWAN, the object immediately captured the attention of the scientific community. But what truly froze scientists in disbelief was its timing. Another object, the already infamous 3I Atlas, was also inbound, racing toward the sun from the exact opposite direction in the sky. Both objects were set to reach their closest approach to the sun within the same 10-day window. Both would be hidden by the sun's glare during their most critical moment, and both were displaying anomalies that seemed to defy the laws of nature. The odds of such a cosmic double arrival happening by chance were so vanishingly small that some scientists stopped calling it a coincidence and quietly began whispering another word: mission. If one interstellar object was strange enough, then the arrival of a second object 100 times larger, targeting the same solar corridor, suggested that we might not be witnessing random accidents of astronomy at all. We might be watching an operation. As data poured in, what first stood out about SWAN was not just its immense size, but its behavior. Unlike typical comets, which scatter light in predictable patterns, SWAN's reflective properties showed metallic signatures, with hints of nickel and cobalt, the same materials humans use to forge durable alloys and protect against corrosion. Some researchers even began calling it the fortress. While most comets break apart under the stress of the sun's intense heat, this one appeared shielded, armored, and capable of maintaining a brightness curve far beyond what natural ice and dust could explain. Its tail, already record-breaking in length, did not behave like chaotic vapor. Instead, it pulsed with subtle, rhythmic changes, almost as if controlled microthrusts were guiding its motion. Imagine watching a skyscraper-sized tank drifting through space, cloaked in a shimmering halo that might not simply be gas, but an electromagnetic shield deflecting the fury of the solar wind. That is the image scientists are now grappling with. But even more unsettling than its enormous scale is its timing. While SWAN looms like a fortress, its smaller counterpart, 3I Atlas, behaves more like a drone, agile, erratic, and capable of strange bursts of acceleration and unexplained changes in the color of its tail. Together, they do not resemble random visitors. They look like two pieces of the same puzzle, converging on the sun at exactly the same time, hidden from us during the very days when their true purpose might be revealed. When astronomers plot the arrival vectors of SWAN and Atlas on a star map, something extraordinary emerges. SWAN approaches from Aquarius, while Atlas arrives from Sagittarius, two origins separated by more than a quarter of the celestial sphere. Yet despite their radically different approach angles, both cross into the inner solar system at nearly the same solar distance, reaching perihelion within just 3 days of one another. Statistically, this level of synchronization is almost impossible. Random comets scatter their arrivals across decades, sometimes even centuries, but never like this. Then comes the blackout. From October 8th to October 18th, the sun's glare blinds our telescopes, creating a period during which neither SWAN nor Atlas can be directly observed. As a result, their closest approach to the sun and to each other occurs precisely when Earth's instruments are unable to watch. To many observers, this appears less like coincidence and more like coordination, as if their paths had been deliberately engineered to meet beneath the cover of solar interference. Think about that. Two anomalies arriving together, timing their rendezvous to the one place and time when we cannot observe them. In orbital dynamics, astronomers call this a corridor, a narrow window of space and time where two objects align in a way that defies randomness. And this corridor, whether by chance or by design, has forced the scientific community to confront a possibility it has long avoided. What if these objects are not simply passing through our solar system? What if they are converging for a purpose? While orbital mechanics raise difficult questions, the energy data raises even greater concerns. Atlas has already shocked researchers with bursts of acceleration that resemble thruster-like maneuvers. Each pulse would require the energy output of roughly 10 nuclear power plants to explain. But Swan makes even that seem insignificant. Its implied energy levels are on the order of 10,000 gigawatts, exceeding the entire electrical power grid of Earth. No known comet nucleus could naturally produce such enormous energy. Its reflective metallic composition, persistent halo, and rhythmic pulses suggest not ordinary outgassing, but deliberate control, more like a machine using bursts of plasma to steer itself through space. The idea of engineered propulsion, once dismissed as science fiction, is now quietly circulating among astronomers who can no longer ignore the numbers. Then there is the timing of the pulses themselves. They are regular enough to resemble a signal, patterned enough to hint at communication, and so remarkably consistent that some researchers have begun calling Swan not a fortress, but a beacon. If Atlas is a drone, constantly maneuvering and adjusting its course, then Swan could be the mothership, a colossal structure built to survive for millennia in interstellar space, arriving now not by chance, but as part of a cycle. With an orbital period estimated to exceed 22,000 years, Swan may have passed through this region long before recorded history, perhaps even during the last ice age, leaving traces that our ancestors remembered as myths, carvings, or ancient warnings. And now it has returned, once again aligned with another anomaly, as if to remind us that we may not be the only intelligence shaping the sky. Just when the world's curiosity reached its peak, silence descended.